Welcome, dear students. Now we discuss MCQ 2021 paper CC-2 Algebra Mathematics Honors, University of Calcutta. Question paper 2022 21. Question 1a. Let n be the set of natural numbers and a relation less than equal to on n is defined by a less than equal to b if and only a less than or equal to b, then n less than equal to correct option 2 poset as well as linearly ordered set. A relation less than equal to is said to be a total order or linearly order on a non-empty set S if the following properties holds. Reflexibility property A less than equal to A for all A belongs to S. Antisymmetric property A less than equal to B and B less than equal to A implies A equal to B. Number 3, tangibility property A less than equal to B and B less than equal to C implies A less than equal to C. And comparability or trichotomy law for any A B belongs to S, either A less than equal to B or B less than equal to A. First three are the axioms of the partial order, and addition of trichotomy law defines the total order or linear order. Clearly, n less than equal to is a partial ordered set poset as well as totally or linearly ordered set. Correct option is 2. Question B. The remainder when 2 to the power 44 is divided by 89. Correct option is 1. Next question 1b is now 2 to the power 6 congruent to minus 25 modulo 89. This implies 2 to the power 6 whole square is congruent to minus 25 whole square modulo 89. Hence 2 to the power 12 congruent to 625 modulo 89, and that is 2 to the power 12 congruent to 2 modulo 89, because if we divide 625 by 89, the residue is 2, and 2 into 2 to the power 11 equal to 2 into 1 modulo 89 congruent to this. So 2 to the power 11 congruent to 1 modulo 89. So 2 to the power 11 to the power 4 congruent to 1 to the power 4 modulo 89. So 2 to the power 44 is congruent to 1 modulo 89. Hence the remainder is 1. Correct option is 1. Question C. F maps set of real numbers R minus 1 minus 1 to map R be function defined by fx equal to 2x minus 1 divided by x square minus 1, then F is the correct option is 4, surjective but not injective. Let R dash is the R minus this set 1 minus 1. Now, so F0 equal to by this, and you put G here x equal to 0, so we get 1. So this is the R dash is the domain set this, and this is the R is the codomain set. So domain set this element 0, image is 1, and for 2 we get this also 1, so we get this. Thus for two different elements x1 equal to 0 and x2 equal to 2 in the domain set R dash, we get same image 1 in the codomain set. Hence this mapping F is not injective mapping. Also, why be any element of the in the codomain set R, then fx equals to y equal to 2x minus 1 by x square minus 1. Clearly, for every y in R, we have pre-image in the domain set R dash. Hence, F is surjective. F is surjective. Hence, the correct option is surjective but not injective. Next question. D. Number of partitions on the set S, 1, A, B, C, D. There is actually no correct answer here. given. Let S be a non-empty set. A partition of S is a collection of disjoint non-empty subset of S whose union is S. The total number of partitions of a finite set of size n, that is the number of elements in n, and by Bell's number Bn is given by Bn is the summation k equal to 0 to n minus 1, n minus 1 ck bk with b0 equal to 1. This whitman.edu from this website. We help from this website. So b1 equal to this 1 and b2 equal to 2, b3 equal to 5, b4 equal to 15, that is equal to 2 to the power 4 minus 1. And for this example ABCD, so this partition P1 only singleton set A, B, C, D, this type of sets is only 1, and P2 these types of sets there are 6 elements, 6 elements AB, AC, AD, BC, BD, and CD. And P8 this type of elements, this ABC 3 elements combined set, this ABC and this singleton set D, this partition, this type of partition 4, and P12 this equal to AB and CD, these 2 elements and these 2 elements, and this type of sets are 3, and P15 this all elements which together, so ABCD, so these types of sets partition is 1, so we get 1 plus 6 plus 4 plus 3 plus 1, so we get 15 partitions here. Next question. E. The values of I to the power I from this GP series. This GP I to the power I equal to exponential I log I, general value of log. This exponential I is the principal value log 1 plus I into twice n pi plus pi by 2. N belongs to the set of all integers Z. So we can write log 1 0. So exponential I square, I into I square, twice n pi plus pi by 2. So this is equal to exponential minus 4 n plus 1 pi by 2. N belongs to set of all integers Z. So I to the power I are all real numbers, this exponential, these types. So I put here n equal to 0, we get this, n equal to 1, we get this, n equal to 2, we get this. So this GP series is the e to the power minus twice pi is the common ratio of this GP series. Next question. If the equation x to the power 5 plus x cube minus x square plus x minus 1 equal to 0 has correct option 4 at least 2 imaginary roots. Here f x equal to this, f of minus equal to this. The sign in the sequence of the coefficients of fx is this plus, plus, minus, plus, minus. So this plus to minus 1 change, minus to plus 1 change, and plus to minus 1 change. There are 3 changes of sign, variation of sign, and therefore the number of positive roots is fx equal to 0 is either 3 or 1. The sign of the sequence is the coefficients of f of minus x, this minus, 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 minus. So there is no variation of signs of the equation fx equal to 0 has no negative roots. The correct option is 4 because the number of positive roots, there are 2 cases. This 3, the complex root is 2, so total number of roots is 5 because this fifth degree equation. And if number of positive roots is 1 and number of complex roots is 4 because there is no negative roots here. So this total number of roots is 5. So at least 2 imaginary roots, either 2 complex roots or 4 complex roots there. So at least 2 imaginary roots. Next question. Question G. If alpha, beta, gamma are the roots of the equation x cube plus qx plus r equal to 0, then the value of summation 1 by alpha square minus beta y is the correct option is 2 minus 3 by q. Clearly, summation alpha equal to 0 because this terms x square terms is absent here. So summation alpha beta equal to q by 1. This summation alpha beta gamma equal to minus r from the relation between roots and coefficients. Now alpha square minus beta gamma equal to alpha into alpha minus beta gamma. This is equal to minus alpha bracket beta plus gamma, because alpha plus beta plus gamma equal to 0 from the summation alpha equal to 0. This means this. So minus alpha beta plus beta gamma plus gamma alpha, this is equal to minus summation alpha beta. This is equal to summation alpha beta equal to q. So this is equal to minus q. So summation 1 by alpha square minus beta gamma, this is equal to 1 by alpha square beta gamma plus 1 by beta square gamma alpha plus 1 by gamma square alpha beta. So this is equal to minus 3 by q. Correct option is 2. Question 8. If f maps n to n be defined by fn equal to n plus 1 cn, the correct option is f is injective but not surjective. Fn equal to n plus 1 cn. So that is factorial n plus 1 by factorial into factorial n plus 1 minus n. So this n plus 1, n belongs to natural numbers. Let x1, x2 be any two distinct elements of the domain set n, and fx1 equal to x1 plus 1 and fx2 equal to x2 plus 1. So when x1 not equal to x2 implies fx1 not equal to fx2. Hence f is an injective mapping. Let y equal to fn, then y equal to n plus 1. This is because fn equal to n plus 1. So n equal to y minus 1. If y equal to 1, then n equal to 0. This 0 does not belongs to the n. So for 1 in the codomain set, there is no preimage in the domain set n, because 0 does not belongs to the set of natural numbers n. So f is not surjective. Hence f is injective but not surjective. Correct option is 1. Question I. The rank of the matrix this is independent of the value alpha and beta. This matrix A, by elementary operation R2 minus alpha R1, we get this B, matrix B. Obviously, this B is a row reduced integral matrix with two non-zero rows, this row, first row and second row, whatever the values of alpha and beta. Hence, rank of B equal to 2, that is equal to rank of A. Hence, the correct option is 4, independent of the values of alpha and beta, rank of A. Question J. System of linear equations x plus 2y plus z equal to 1, 2x plus y plus 3z equal to b, x minus 4y plus 3z equal to b plus 1 has infinitely many solutions if b equal to 4. The augmented matrix of the system, this 1, 2, 1, 2, 1, 3, 1 minus 4, 3, and this 1b right hand side vector, this 1b, b plus 1. By elementary row operation, we get this augmented matrix reduces to this type. So this solution system has many solutions, infinitely many solutions. If 4 minus b equal to 0, that is if b equal to 4, is rank of A. Rank of A is this 2, and if b equal to rank of A bar is also 2, which is less than 3. Number of elements is 3. So the system has many solutions, there are infinitely many solutions if b equal to 4. Correct option is 1. Thank you for watching this.